Hello maths fans, we're looking at the general form of the equation of a straight line. So what is the general form? It is when we write the equation of a straight line in this form, ax plus by equals d. Ax plus by equals d. Now there are some slight edits you could see for that one. You may see ax plus by plus d equals 0, but it's that kind of basic idea there. So here is the equation of a straight line in that form. We've got something times x, a coefficient of x, coefficient of y equals a whole number. And as, we try and keep that all as integers, all as whole numbers. So that is the general form of the equation of a straight line. Now there's other ways of writing the equation of a straight line, but this form is particularly useful when we want to find x and y intercepts. So we'll have a little look at finding the x and y intercepts, and you'll see how easy it is. So I want to know where this crosses the y-axis and where it crosses the x-axis. Let's start off by finding the y-intercept. Well, the y-intercept, where it crosses the y-axis, is going to be when x is 0. On the x-axis there, if I'm at 0, that is the y-axis. So I'm looking for putting in that number x equals 0. And if I substitute x equals 0 in here, 6 times 0 is 0. Well, that means that 5y equals 30. And I'm going to simply do divide by 5, and I get y equals 6. So it's as simple as that. When you're substituting in 0, life is easy because it just cancels out the x's. There are 0 x's in there. 6 times 0 is 0. And so I get the coordinate 0, 6 for my y-intercept. 0, 6. So I'll go up there and I'll plot 0, 6. To find the x-intercept, I'm going to do something very similar, but this time I'm going to substitute in where y equals 0. So my y-coordinate is 0, and if you think about the y-axis there, when I'm at 0, I must be on the x-axis. So when I substitute 0 in here, I get 6x plus 5 times 0, that's going to be 0. And so therefore 6x equals 30. Divide by 6 and I get x equals 5. And so when x equals 5, y equals 0. Now if I plot those points, my 0, 6 and my 5, 0, along 5 up 0, and then I join those up with a straight line. Let's see if I can get this fairly straight. Not brilliant, but not too bad either. That is a sketch of the graph 6x plus 5y equals 30. So the reason it's so useful is because when I substitute in 0 into either of these, I get a very quick solution and I can find my intercepts, my x and y intercepts. Alright, here's one for you to try. So I'm suggesting pause the video, try and draw a little sketch in your exercise book. Find the x and y intercepts for the line 3x minus 2y equals 12. Now this has a negative in it, so it's not quite the same as the last one, but give it a go. Pause now, and I'll show you the solution in a sec. Okay, here is the solution for that one, the x and the y intercepts. So when we substitute in x equals 0, we'd get minus 2y equals 12, and therefore y equals minus 6. And that's this coordinate. When I substitute in y equals 0, I would get 3x equals 12, therefore x equals 4, along 4 up 0. And that is a sketch of the line 3x minus 2y equals 12. Moving on then. So we've said the general form is ax plus by equals d. And I also mentioned when you look in the formula booklet, if you're studying IB, then that is very, very similar to this. It's basically taken the d over to the other side and made it equal to 0. But that's another version of the general form. So there's three forms that you'll see in an IB formula booklet. gradient intercept form, y equals mx plus c. You've got point gradient form, which is useful if you're given a point and you're given the gradient. You can really quickly substitute in to find an equation. And it depends what you're trying to do. If you're finding x and y intercepts, the one we've been using here, the general form, is probably the most useful. We can also go from that general form to the gradient because we find an x-intercept, we find a y-intercept, and therefore we've got two coordinates to work out the gradient. It is the worst one for finding the gradient. This one, the gradient's pretty obvious. This one, the gradient's pretty obvious. So it is possible to find the gradient. And in fact, I'll show you a shortcut in a second. But depends what you want to do as to which one of these forms you might want your equation in. Okay, here we have an equation that is in gradient intercept form, y equals mx plus c. And we want to turn it into the general form. Well, this is just rearranging. All I have to do is make sure, well, I know that the general form is ax plus by equals d. And therefore, let's just check that. And therefore, what I'm going to do is I'm going to multiply by 3 so that I haven't got a fraction here. Then I'm going to add 2x to both sides. So when I multiply by 3, I get 3y equals minus 2x plus 6. Multiply everything by 3. And then I can rearrange this, add the 2x, and I get 2x plus 3y equals 6. We're looking for integers here. We want it as whole numbers. All right. Here's 2 for you to try. Same idea applies. Try and get rid of the fractions there so that you've got whole numbers, and write these two equations in the general form. Pause the video now, give it a go, and here's your solutions. So this one, very simple, just add 4x to both sides. This one over here, we have to multiply by 4, which cancels out those two fractions there, and we get 4y equals minus 3x plus 5. Then I add 3x to both sides. Add 3x, and I end up with 3x plus 4y equals 5. And that's it. It's in the general form. Useful to be able to do. One last point, one last thing to recognise is that there is a shortcut for finding the gradient. If you have it in this form, the a and the b there can be used to find the gradient, and it will be negative a divided by b. So you take the coefficient of x, divide it by the coefficient of y, and make it negative. For example, if we have 4x plus 3y equals 10, the gradient will be 4 over 3, and then make it negative. Negative 4/3. All right, that is the general form of the equation of a straight line.